For your fifth Fantastic Five, we're going to look at the problems that you really need to focus on for the test. The first problem is write in word form this number right here. Two things I want you to really focus on are the decimal, which is always read as and the commas, which separate your groups of three numbers, and they always tell you your word to say. At that point, you say your word, whatever it is, billions, millions, thousands. I mean, it can go way up into past billions, but that's your word choice. So this word is 7,000, where the comma goes. No and goes right here. You just keep reading until you see your decimal. 400. Now here's your and. And then just read the number like you normally would. 606. And then stick the ending on, whatever the ending value should be. And since that last 6 right there ends in the thousandths place, you're going to end with the word thousandths. And that is how you write your word form of that number right there. Number 2, write an equation to represent the difference of a number and 3 is 10. Highlight your important parts first, it'll help you, and the important parts are difference, that means subtract, a number, which means a variable, any variable you choose, 3 is means equals, and 10. So we have the difference, which is our subtraction sign. I'm going to stick that out there first, if you can see that. And we're going to find the difference of a number. I'm going to call that x, because in middle school a lot of times they're going to call that x. So go with x. And 3 is equals, and that equals 10. So the difference of a number x and 3 is equals 10. Now, a lot of people in class with me were saying, well, wouldn't that be 7? Well, does 7 minus 3 equal 10? No. You have to do the reverse here, the inverse operation, to figure out what the x is going to equal. And x actually equals 13, because 13 minus 3 equals 10. The equation must balance, just like a balance that you see in class. For the third question, how many faces does a triangular prism have? If you look at just a regular old triangle, you know that it has this face, and then it has that face also on the back of it. So I'm just redrawing you the figure here. So it has 2 faces there. And then if you connect your lines, you'll see that I've created one face right there on the front, one face on the bottom right there, and then that back face. So we have 1, 2, 3, 4, and 5 faces for that figure. We have 5 faces for that figure. It has 5 faces. And for the fourth one, what is circumference? I said it's like the belt that goes around the circle, but it is that area, it's the perimeter around that figure. So if you have a circle, we're talking about the perimeter around the circle, all the way around the circle. We describe this one line that I just drew as the diameter. Half of the diameter, if you could break it in half, would be the radius. So the circumference is the perimeter around the circle. Like the perimeter around the room, it would be the perimeter around the circle. For number 5 here, if Michael has 12 marbles, 3 of them are blue, 6 are green, 2 are red, and the rest are white, what is the probability that he would select a white marble? First of all, we have to figure out what the fraction is. We know that 3/12 is blue, 6/12 are green, 2/12 are red, and we don't know what 12th is white. But if we look at these fractions right here, we can figure out what the whole is, because we know how to work with fractions. And we know that our whole is going to be 12/12. So, sorry, I'm trying to catch up. If 3/12 plus 6/12 plus 2/12 equals 11, you're going to have only 1/12 left over to be your white marble. A whole in any occasion, in any number sense, is whatever the base is, whatever your denominator is, over your numerator, and they would be the same thing. 12/12 is a whole. 12 parts out of the entire 12. You do your quick math facts right here. You can see that either 3 and 5, I grouped those together quickly, that 3 and 2 is 5. And 5 more is 10 plus the 1 extra and the 6. So that's 11/12 that we get out of here. This is 11/12. So what's remaining is 1/12. 1/12 is how many white marbles there would be. And moving right up to our turning fractions into decimals. What fun this is. We actually are working with this right now. All you have to do is divide your bottom into your top, your base, your denominator into your numerator, and set it up like a normal division problem, something that you're used to. So if we divide, whoa, Miss Murphy, what are you doing? If you divide 9, your denominator, into your numerator, which is 5, we know that that doesn't really happen. But we know, like money, a decimal and some zeros are always hanging out there. We just don't write them because it's a complete waste of our time unless we need to. And in this case, since we're having to write this as a decimal, we need to. So we're going to shoot up our decimal onto that fraction line right there and go about this problem like we normally would. 9 does not go into 5. It goes in 0 times. 0 times 9 is 0, so on and so forth. But 9 can go into 50. 9 goes in to 50. Sorry, 9 goes into 50 5 times. 5 times 9 is 45. When you subtract 50 and 45, that's one of those math facts you should know, because any 10 minus 5 is 5. You bring down your 0, and 9 goes into 50 again 5 times. This process is going to keep repeating, as you can see, and I'll drag it out for you for just a second. We'll have 5 left from that. If I add another 0, bring down my 0, 9 goes into another 55 times. If that is going to be the same subtraction problem I'm ending up with every time, we call that a repeating decimal. And you can just ignore the rest of it and call it a repeating decimal and stick that line over it to show that it is a repeating decimal. So A is the best answer there for your repeating decimal. For number 2 here, on 47, write the next 2 numbers in the pattern. First of all, you need to figure out what the pattern is and explain how you got it. So look at the relationship between each one, how you get from here to here, so on and so forth. Usually you need to think about things outside of the box, not just the normal one-step things, but 2-step things that you can get from here to there. But I noticed right away that I'm adding 2 right here, I'm adding 3, I'm adding 4, so I'm going to add 5 and I'm going to get 15, and then I'm going to add 6 and I'm going to get 16. So each time we are adding one more. Sorry, the handwriting isn't great with a mouse and a couch, so you'll have to bear with me. Number 3, identify this this polygon. It is not a quadrilateral. Excuse me, a quadrilateral means 4, and I already see that this shape does not have 4 sides. The shape has 1, 2, 3, 4, 5 sides, and a 5-sided shape is just like your Pentagon in Washington, and the Pentagon in Washington looks just like this shape right here. Hex, we remember a hex, putting a hex in somebody, that's the 6-sided shape, that's that bad number. Hexagon. For number 4, what do both pi times diameter and 2 pi r, why do they both work to find the circumference of a circle? If you go back to that one we were looking at earlier with the circle, of course I got ahead of myself. We said that half of this, just this half right here, is the radius, but the whole thing is the diameter. So if you look back, pi is that magic number for circles that we use. But they mean the same thing. You're just multiplying your radius here, which was half of a circle. There's your radius. And your diameter is the whole length. So multiply that by 2 or call it diameter, whatever. You're still doing the same thing, multiplying it by pi to find the circumference. And remember that pi equals 3.14. And when you get to high school, you'll get to memorize the entire number that keeps on going forever and ever and ever. I'm going to do my multiple infinity signs just because they're fun. And number 5, Samantha recorded the following data, which is information. Would this information come from a survey or an observation, and how do you know? The type of data that we have from this is about favorite animals. Whenever you see favorite, I want you to think about how you get to know somebody's favorites. Can you observe somebody's favorite color? I don't know. I mean, maybe if they're decked out from head to toe in pink, or they could have lost a bet, or anything along those lines. So this is something that they would have to be asked about. So the survey would be the best option there. Your survey would be your best answer for that question. I hope this has helped you, and we will meet again.